Hello guys, welcome back to my channel. Hope you're feeling fine today. In this video, we're going to learn how to construct a confidence interval for a point estimate in Python. So we continue the same example of previous videos, the videos titled with normal distribution and sampling distributions with Python. So as you know, we're analyzing data on the literacy rate for each district of a nation. And we were only able to survey 50 randomly selected districts instead of all 634 districts. And we used Python to simulate taking a random sample of 50 districts and making a point estimate of the population mean or literacy rate for all districts. So now we want to construct a 95% confidence interval for our estimate of the mean district literacy rate. As usual, first we import the Python packages we want to use, NumPy, Pandas, and from SciPy import stats. We use the same sample data that we worked with in the previous video. If you don't know what I have done and how to take a sample, go and check that video that I said, titled with sampling distributions with Python. So now we display the value of the variable. The output shows 50 districts selected randomly from our dataset, and that each has a different literacy rate. And now we can construct a confidence interval for this sample. But first, let's review the steps for constructing a confidence interval. First, we need to identify a sample statistic. Second, we choose a confidence level. Third, we find the margin of error. And fourth, we calculate the interval. With Python, we can construct a confidence interval with just a single line of code, and it is quite easy. You need to know that if you're working with a large sample size, say for example larger than 30, you can construct the confidence interval for the mean using SciPy stats.norm.interval function. As you can see, this function has 3 arguments. In some versions of stats models, it is called alpha, but mine is called confidence, which it is quite obvious that it is the confidence level. And log refers to the sample mean, and scale refers to the sample standard error. So here alpha or confidence is 95%, and for log we have calculated before with a variable called sample_mean. And the last one, which is the scale, is calculated through the formula of sample standard error, which is the sample standard deviation divided by the square root of the sample size. So we write a code to do that for us. First, we name a new variable, estimated_standard_error. Next, we take the standard deviation of our sample data and divide it by the square root of our sample. And then, in parentheses, we write the name of our data frame followed by the shape function and 0 in the brackets. Because we want to return only the number of rows, that is the same number as our sample size. We did all this to get the formula of sample standard error. And now we put all this together to construct our confidence interval with the stats.norm.interval function. So we run the code, and the output is our confidence interval. We have a 95% confidence interval for the mean district literacy rate that stretches from about 71.4% to 77%. And that's it. So far so good, right? And now imagine that we want to be even more confident about our results, and we recalculated our interval with a 99% confidence interval. We copy and paste the same previous code, but change our alpha from 95% to 99 or 0.95 to 0.99. to compute a 99% confidence interval based on the sample data. And we run the code. So we have a 99% confidence interval for the mean district literacy rate that stretches from about 70.5% to 77.9%. We can see that when we compare it with the 95% confidence interval, we notice that as the confidence level gets higher, the confidence interval gets wider. With a confidence level of 95%, the interval covers 5.6% points, while with a confidence level of 99%, the interval covers 7% points. And this is because a wider confidence interval is more likely to include the actual population parameter. So what is important here is that both our confidence intervals capture the actual population mean of 73.4%. And that's it. Thank you so much for watching this video. I hope you liked it, and I'll see you in the next video.